Hello everyone, this lecture video is all about lipid digestion and absorption. So, foods such as fish, meat, oil, nuts and seeds, and dairy products such as milk and butter, they all comprises the dietary fats as we call it. And this dietary fats contains the lipids, which is a fat-like molecules that does not have the ability to dissolve in water. So, of course, the digestion will start in the mouth, but the saliva here has no effect in the digestion. So, by the time that you have swallowed the food, it does not have been dissolved until it will reach the stomach. Here in the stomach, the churning action of the stomach and the gastric lipases, these are the digestive enzymes responsible for the hydrolysis of the food. But here in the stomach, there is only a little effect. So this churning action in the stomach will produce fat droplets and chyme. When we say chyme, let me write that. Chyme, okay, it is a mixture of solid food that has the gastric juices on it. So the fat from your mouth has not been thoroughly digested here. It does not have any chemical digestion that occurs. So it is more on physical digestion rather than chemical. So that happens because the fats that you have intaken, let's say has these fats here, it doesn't like water, so it doesn't dissolve in water. So when that happens, these molecules gather into clumps. They form clumps, large clumps. And this is what we call the chyme. So this chyme will pass into the small intestine here. Until it reaches the small intestine, it doesn't have any change on it. It doesn't been dissolved thoroughly. And then, once in the small intestine, the bile salts from the liver will act as an emulsifier of lipids. When we say emulsifier, it will break the large fat droplets into smaller droplets. Just like this, the bile salts will act on the chyme and it will produce smaller droplets. So, next, the pancreatic enzymes or pancreatic lipases, which are the fat-digesting enzymes. This is where the chemical digestion, as we call it, will occur because it will produce monoacid glycerols, which will form fatty acid molecules. So, it will coat the fat or the dissolved chyme or the broken down chymes, and it will produce free fatty acids or the basic unit of the triacyl glycerols. So, these free fatty acids will now pass through the intestinal cells. This is the intestinal cell. It will pass through the epithelial cells here inside that. This is your free fatty acids. It will pass through that. Once inside the epithelial cell, they will enter the endoplasmic reticulum, which is a cell organelle that synthesizes and transports lipids. So, this is the ER here, or the endoplasmic reticulum, and this is your free fatty acids. Now, inside the ER, there will be a unique way in which the free fatty acids will be repacked or will be reformed or reorganized into triacyl glycerols. Now, this absorption of triacyl glycerols or free fatty acids is different from carbs and amino acids because in the digestion and absorption of amino acids, you can see them in their smaller or basic units, but here they are resynthesized into triacyl glycerols and not in free fatty acid form. So before this triacyl glycerol leave the epithelial cell, it will be coated. So just like what I said earlier, this ER is one of the responsible in the transport and synthesis of the lipids. So here it will coat, inside the ER, it will coat these triacyl glycerols with chylomicrons. So this chylomicrons is a protein that transports lipids into the lymphatic system. It composed of small globules of proteins and lipids. So these chylomicrons here in the epithelial cells is a protein coating. It gives the triacyl glycerols a water-soluble coat. So this water-soluble coat allows the chylomicrons to travel outside the cell because they became water-soluble in this part. Now the chylomicrons will leave the epithelial cells and the ER. It will now be transported into lymphatic system here, or what we call the lacteals. So these lacteals are located and can be found inside the villi. So this is your villi in the small intestine, and here are the lacteals. So these lacteals here connect this into lymphatic system, in which the lymphatic system, this is their pathway to the bloodstream because the chylomicrons will now be passed through in the thoracic duct, which can be found in near our lower collarbone. So this is the largest lymphatic trunk which drains chyle or product of fat digestion and most lymph of the body. So it drains that here. So you can find this in your collarbone and in your neck as well. So that is why there is sometimes you will feel a little bit uneasy when you eat too much food because there is an accumulation of fats in your thoracic duct. So the absorption of triacylglycerols through lymphatic system displays another unique way of absorption compared to amino acids and carbohydrates. So amino acids and carbohydrates directly enters the bloodstream through the blood capillaries. Here it will enter first the lymphatic system before proceeding to the bloodstream. So once in the bloodstream, okay, the triacylglycerols will now be hydrolyzed using the lipoprotein lipases to produce free fatty acids. So they will be splitted. These triacylglycerols will be repleted or will be hydrolyzed into smaller forms into free fatty acids. And then once in the bloodstream, again, triacylglycerols are hydrolyzed to free fatty acids with the aid of lipoprotein lipases. And then once in free fatty acid form, they help in building cell membranes. Here, as you can see, those are fats in the cholesterol form. And also, they help make the myelin sheaths in the nerve cells. This is your nerve cell, and these are the myelin sheaths. It gives protective coating on the nerve cell. And then, it insulates the body, meaning to say, it keeps us warm and safe from electric shocks outside and inside of our body. And it is also our alternate fuel source. So for example, you are in fasting mode and you don't have the carbs readily with you, this can be converted into glucose as energy reservoir in our body. And then what else? So you cannot have too much of fats because eating too much will lead to the accumulation of your free fatty acids and triacylglycerols in your body. So when that happens, you are more prone and there is a higher risk of you in heart disease. So you should avoid too much consumption of fatty acids. So there is what we call the good fats and bad fats. So good fats and then the bad fats. So saturated fats are known as bad fats because they tend to be solid at room temperature and from animal sources, so they can't be easily digested. And when that happens, they accumulate in your bloodstream. Unlike the unsaturated fats, in which we call the good fats, they are usually liquid and from plant sources. When they are in liquid form, okay, they can be easily digested. Your blood looks like if you have a too much accumulation of fats, and this is as well. You see, it is very much concentrated of fats. But if you will undergo a 30-hour fasting, you can have a purer form of blood free of, or at least a little amount of cholesterol in your blood. So let us have a summary for that. Where is that? Here it is. So digestion of lipids will start when you intake a dietary fat through your mouth, and the saliva has no effect on the physical digestion of fat in your mouth. So that will be passed through into stomach, and then it will produce a chyme, which is a combination of gastric juices and the churning effect of digestion. So this is a semi-liquid form of fats. Okay, so that is a fat droplet. So this is more on physical digestion rather than chemical digestion, because the chemical digestion will occur in the small intestine, in which it will produce or it will break down the fat droplets with the aid of the bile salts and pancreatic enzymes or pancreatic lipases. It will break down into monoacylglycerols, in which it will convert it into free fatty acids, and then it will enter the intestinal cells. So once inside the intestinal cells, it will enter the epithelial cells and the endoplasmic reticulum. So once inside the endoplasmic reticulum, it will be repackaged or it will be reorganized into triacylglycerides. This is with the help of the coating protein chylomicrons. So the triacylglycerols that has been coated with chylomicrons will now enter the lymphatic system through the lacteals in the villi. Now, through the lymphatic system, it will be able to pass through in the bloodstream, and once in the bloodstream, it will be hydrolyzed using the lipoproteins, and you will now have the free fatty acids in the bloodstream. So that is all for lipid digestion and absorption.